Welcome to DC Circuit Analysis. Today we're going to talk about Kirchhoffs Current Law with tips and examples. This is the concept for KCL. It states that the algebraic sum of the currents at the node is 0, meaning that all current entering into a node is equal to all the current going out. In this example, we have this, all entering I1, I2, I3. The sum of these is equal to the sum of I4, I5, and I6, which are going out currents. Therefore, we have this general expression. So this is in correspondence with the law of conservation of charges. So basically, it's analogous or similar with the law of conservation of energy. So the charges are neither created nor destroyed inside the node. So these are the steps when we're going to deal with KCL. First, simplify the circuit and transform any voltage source into a current source. Okay, so you see in the yellow, this part here, so you have a voltage source. So this is the internal resistance of a voltage source, and this is the source itself. Then we conduct source transformation, and this becomes like this. So the voltage source becomes a current source, and the value of the current source we can solve it using the Ohm's law. Okay, so I is equal to V over R. In that case, 5 divided by 2. And then we also have the internal resistance of a current source, which is connected in parallel with the current source. And the value of the internal resistance is similar to the internal resistance of the voltage source. That's the first step. Then the second step, we have assign branch currents. So here we have the different branch currents. So take note of the branch. A branch is a line of wire with a single element, electrical element. It can be resistor, it can be current source, it can be voltage source. So we have here one branch, and this current here, the current flowing here is 1 ampere. Here we assign I1, here we assign I2. In this branch we assign I3, and then here I4, and then here I5 over 2. Okay, and the assignment depends on you. This is arbitrary, so you can assign any other variable as you please. Then third, label the nodes. So what are the nodes in the circuit? So here are the nodes. So actually these are the nodes in this case. This is node C, and this is node B, node A. Okay, meaning that you can convert that circuit into like this. Meaning that all of this current here flowing enters this node. So you can imagine a single node here. Okay, that's very important. So we have discussed node and then also the branch current. Okay. And then fourth, we have to construct KCL equations based on what is the concept of KCL. So here, the summation of current going in the node is equal to the current going out of the node. So in this case, we have subtraction of current N with a summation of current going out. So we have three nodes A, B, C. So in the first node A, so the current going in is the 1 ampere source, and then we have I1 going in, and then going out is I2. Therefore, we put a negative sign here. Okay, and for node B, so we have I2. Okay, I2 going inside node B, and then we have 5 over 2, and then I4, all positive, except I3 going away from node B. And then we have node C. Node C, you can see I3 going in, and then the rest 1, and then I1, and then I4, and then 5 over 2, all of them are going away from the node C. So we have constructed three equations, KCL equations. And lastly, we solve for a known current. So given these equations, we can construct a system of linear equations, and then we can solve for the unknown current. For example, we're going to find I3 or maybe I2. So it depends on the problem. That's it. So let's try some example. So here we would like to solve for unknown I2. So here I2 is current across 3 ohms going to the left. Okay. So first step, we need to convert the voltage source into the current source. So this is the same example as the previous one. So 5 over 2, so therefore this is 2.5 ampere. And then, okay, that's the first step. And if you look at it, there's 2 resistors. We're not concerned of these 2 resistors, we're only concerned of this resistor. Therefore, we can take the parallel combination of the 2 resistors. And we have this equivalent value, so which is a 1 ohm. So if we construct if we combine the 2 resistors, we have 1 ohm. Okay, in this case, we have replaced the 2 resistors into 1 resistor. Why is it? Because if you don't combine the 2 resistors, you will have 2 currents, no? And we know that every unknown current is a variable, and it will make us difficult. It will give us a difficult time looking for the variable I2, because it will increase the number of variables. So in order to simply assign one current, so parallel combination is very good. Then we have step 2. So step 2, if you can remember, we assign different current. Okay, so I1, we assign I1 in 2 ohms, and then for 1 ohm, we assign here I3. Okay. So you see, we only have 3 variables, 3 currents. Otherwise, if you don't conduct parallel, so we may have 4 variables, and we need 4 equations to solve for all the variables. Okay. And for step 3, we need to assign the nodes. So we have A, B, and C. Okay. And in the step 3, so we can do the step 4, which is conducting KCL equations. And we know that there are 3 nodes, therefore there are 3 equations. And as you can see, in step 5, we can arrange the equations, the 3 equations. So then we know that there are 3 variables, I1, I2, I3. Given the 3 equations, 3 unknowns, then we can solve for any of the variables here, I1, I2, or I3. But we're concerned with solving I2. Okay, we can solve it using substitution method, any numerical methods, or even calculator. Okay, so it's quite familiar this one for a matrix form, but we're only concerned with I2. Okay, so you can solve it on yourself. But the idea, we applied the 5 steps for KCL. Okay, that's it. Very good. For the summary of this lesson, just remember, all the currents going in minus all the current going out is equal to 0. And then we have the 5 steps: simplification and transformation of voltage source to current source, assignment of branch current, label the nodes, construct KCL equations in each node, and lastly, solve for the unknown current. Okay, so we have learned source transformation. In this case, it simply follows the Ohm's law. If you don't know about Ohm's law, so I would like you to watch the previous lessons, and I would like you to also watch the applied KVL for general circuits, nodal circuit analysis. So actually simply KVL plus Ohm's law and other concepts, and this one is really easy and convenient to solve all general all circuits concerned. Okay, so that's it. Thank you for watching this video. See you soon.